All right, I'm going to be starting this next example. And by the way, I think this next example is wrong. Considering the graph y is equal to 1 over x plus 2 minus 3. How does the graph compare to the graph of y is equal to 1 over x? So I've just simply graphed the graph y is equal to 1 over x. You may press pause and graph this basic function so that we can sort of begin and make comparisons. And then hopefully we can conclude that this is wrong. I believe here we're talking about transformations. We're going to try to use transformations, and when we're dealing with hyperbola, which is what we have here, really important signposts of rational functions are the vertical and horizontal asymptotes. They're basically the rules that govern the graph's behavior. So how does y is equal to 1 over x? How do these asymptotes compare to these asymptotes? Well, it appears that h got shuffled over. We moved the horizontal -2 over to the left. And it seems like, sorry, the vertical 2 to the left. Now the horizontal looks like we shifted it 3 down. All right, that's good. So I think that x plus 2 minus 3 here, I think that those are correct if I'm comparing it to this and applying my different transformations. So now I believe this is not correct overall. Now, just bear with me for a second. I'm going to switch my pens up to green. For those of you who are really keen, let's talk about this. On the left-hand side, my graph is decreasing here. It is going downhill as we approach the vertical asymptote. But on my other graph, my horizontal asymptote is going, as my graph is going up as I approach the vertical asymptote. So it almost appears here that A is equal to -1. In other words, my graph was reflected. Also, and now this is really unfair. I would really consider this an unfair question. Now, let's take a look at what the absolute value of A is. So A is negative. I'm going to say -1. I'm just going to say negative. So let's try to figure out if this graph was stretched or not. So what I'm going to do is I'm going to take, again, how did my graph y is equal to 1 over x? As I went over 1 unit, I went up 1 unit. But yet, when I go over 1 unit, my graph looks like it goes down 2 units. So the absolute value is 2. It got stretched vertically from a factor of 2. Putting these two together, I would say A is equal to -2, which is not reflected in the question. So how does this graph compare to 1 over x? Well, it appears that the graph was reflected about the x-axis, stretched by a factor of 2, shifted 2 units to the left, shifted 3 units up. Ouch, that hurt. That is a very tough question. All right, generally speaking, we can transform the graph y is equal to 1 over x into a rational function. Y is equal to A divided by x minus h plus k, where the parameters a, h, and k are those seen in previous lessons. So if A is negative, we reflect. Notice that there's no B here. I'm going to say A stretches vertically by the absolute value of A, too. So we have to be careful of that. So A can be found up top. H and K, this is all good. All right, here we are. Sketch the graph of the function using transformations. Identify the domain, range, intercepts, and the asymptotes. So really, what is this question about? It is starting off with the basic, this. We start off with y is equal to 1 over x, and we're going to transform that. So let's start off there. I have started by graphing my function y is equal to 1 over x, which is the hyperbola, basic hyperbola. Now I'm going to pick out the values of a, h, and k. So I'm going to press pause. You pick out the values of a, h, and k. Go. There are my values a, h, and k. Right? So I'm going to just rewrite this in another way. I could also write this as y is equal to negative 3 over x minus 2 plus 1. That would be another way, which makes that much more apparent. So there are 4 different transformations. We need to reflect this about the x-axis. We need to shift 2 units right. Also, we need to shift 1 unit up. And by the way, these shifts actually are the things that move the horizontal and vertical asymptotes. So if you want, we can move the horizontal and vertical asymptotes here. I know generally speaking we try not to do that, but it definitely can give you a hand up. So maybe you may want to write that in your notes, is you can shift the vertical and horizontal asymptotes without fear of ruining your function. But I'm going to try to keep it consistent. Here we are. So I am going to start off my transformations. So this is y is equal to 1 over x. That should have been green. My apologies. Y is equal to 1 over x. What I'm going to do is next, I'm going to stretch by a factor of 3. Now, if you notice, I picked out my points here and I made them fairly obvious and easy to work with. If I stretch this by a factor of 3, my y value is 2, it goes up to 6. My y value is 1, it goes up to 3. My y value is half, it's going to go up to 1.5. So there's my new hyperbola. Over here, my y value is a half, multiplied by 3. Sorry, my y value is negative half, multiplied by 3, it's negative 3 halves. My y value is negative 1. Goes down to negative 3. My y value is negative 2. Uh-oh, ran out of space. It's going to go down to negative 6. Now, I'm sure hoping we shift this up. Anyways, we know that I haven't shifted my horizontal or vertical asymptotes yet, right? Those are only shifted with my horizontal and vertical shifts. There we have it. So I always like to put my dots in a different color. Here for you, that was that. There we are. Just to help us along. And if you notice, I use my asymptotes as a guiding line to graph my function. Now I'm going to go with my next function, and that would be to reflect about the x-axis. So I'm going to press pause, and I would like you to do that right now. There we have it. So I've added some things here while I was working. For instance, I put point form to help me out in my thoughts. Really what I did is I took this point here, x comma 3/2 or negative 3/2, and I just simply reflected that into the x-axis by taking my y values I had previously and just making them positive, essentially, multiplying by negative 1. So, and then this was negative 3, or sorry, that was positive 3, so I moved it down there. This was positive 6, kept the x values the same, and I should have a point right here. Turns it into negative 6. Anyways, it was good. And now I just have to shift this 2 units up, or sorry, 2 units right, 1 unit up. So this is looking ugly here, but just trust me, now we get to move the horizontal and vertical asymptotes. So I'm going to take an interesting color here, like perhaps, let's see, oh, a gray. So the next thing I'm going to do is I'm going to shift it 2 units to the right. So since I shifted 2 units to the right, it changes my, I have to remember, it changes my, basically takes this whole graph, lifts it up 2 units to the right, does not change my vertical asymptotes, just change my horizontal asymptotes. It's a little bit too pale there. We switch to a darker gray. There we have it. So now I am working off the red graph, so I go 2 units to the right. 1, 2. 1, 2. 1, 2. 1, 2. Working off the red, go 2 units to the right, 2 units to the right, 2 units to the right, about right there. Now I just have to really make sure that my graph is observing my horizontal and vertical asymptotes still. There we have it. I'm hoping this looks nicer on your paper than mine. Last but not least, I'm going to change my color to lime green, and I'm just going to, by the way, that took point x plus 2 comma 3y, and now I'm just going to shift it 1 unit up. So this shifts, now I'm working off the gray, so it shifts my vertical asymptote 1 unit up, so there's my vertical asymptote line. And my horizontal asymptote, since it's a vertical shift, my horizontal will stay the same. So got a little bit lazy there towards the end. And now I'm working off the gray, so I shift them up. Oh, I just shift my Y value up 1 unit. So working off the gray, up 1, up 1, up 1. Now I'm just looking for the overall shape there. Hope that's okay with you guys. I shift it up 1, up 1, up 1, maybe up 1. So I know it's a lot of confusion on that graph, but the green one is the transformed form. These points are probably the hardest to transform. Good luck. If you have any questions, please ask in class. Now, my suggestion to you is take 3 points per side and then graph it. Have a good day.